today we're featuring CNC Software, and you know that product better as MasterCAM. MasterCAM has released a product, or has for a while now, had a product that runs directly inside SolidWorks, and that's what we'll be looking at today. My name is Craig Terrian. I'm a product manager here at SolidWorks, and on the line with me is Keith Busby. He's with CNC Software, MasterCAM. He's a technical specialist, and I also have Dan Martin online with us, and he's going to be telling us some his experience actually using both SolidWorks and MasterCAM, and Dan's company is Summit Tooling. So just to give you a little background, what is the CAD/CAM Slam webinar series? Well, we're doing this series really to introduce SolidWorks customers and introduce CAM customers, people who already have CAM systems, people who are looking at CAM systems, introduce them to the concept of fully integrated CAD and CAM, mainly using SolidWorks and using our CAM partners that are fully integrated. What you will see in this webinar series, so there's a series of a number of these webinars that we're doing. What you'll see is SolidWorks Certified Gold Product CAM Partners. So these are companies that have been certified by SolidWorks, and they have products that run directly inside SolidWorks. So you can work in SolidWorks, never have to leave that environment. Okay, just so you know, where do you find more partner info on SolidWorks.com? The way you find that is you go to our main web page, go to SolidWorks.com, and you basically look on your search area, and you can type in the partner you're looking for, or you can go to our products area, and you can look under our partner products area. You can actually search by company, product, or any keyword you want. First, what I'd like to talk to you first about is one of the key reasons, one of the big reasons that we want to show CAD and CAM working together is to solve a problem that we see is pretty prevalent in the industry right now. What I call the non-integrated design through manufacturing process. And in this example, I'm going to use the mold design. In other words, take a plastic part, mold design, all the way through NC as an example of this, because it's one of the more extreme cases. So first, let's say we have a certain CAD system. We start off with a plastic part, and then we go and say, okay, we want to bring this send it to our tooling vendor, or maybe even within our own company. We might be using a different CAD system to do the mold design portion. So typically what I have to do is export, and then import, and probably even repair some of that geometry. That goes into my mold design system, and I find some draft errors there. I maybe fix those draft issues, maybe do some mold inserts. And then when I go to do my drawings, I might actually go to another CAD system. So there again, I might export and re-import. And then when I go to CAM, I might go to another CAD system, another CAM system outside of the one I have now. And you see along the process, you have all these red boxes, and these are really places that you're stopping. You have to do something that you really don't want to do. You have to export, import, and sometimes repair your geometry. So what happens now when a design change comes along? Well, unfortunately, you have to start the whole process over again. You have to import the data into your mold system, import it into your drawing system, import it into your CAM system. This takes a lot of time, and it creates barriers. Secondly, it puts the accuracy of your geometry in jeopardy. All right. Thirdly, it thwarts concurrent design. So in other words, you're not able to work on the model and work on your NC toolpaths and work on the mold and work at the drawing all at the same time. Fourth, it's extremely time-consuming. There was a study done a while back by a consulting company that basically said about 70% of the time designing, actually working in the CAD system, in this case it was the mold design process, people were spending doing this import and repair of data, 70% of the time. So imagine if all your systems could talk to each other seamlessly, how much time you could save. The other thing is it's expensive to maintain and train people on multiple systems. You have maintenance dollars to pay. You have training to get people up to speed. So that's a big pain also. So let's look at another way you could do the same design process. I call this the integrated design through manufacturing process. So in this process, you have the same design points. You have plastic part design, discover draft issues, make the mold. You have mold inserts, maybe even have some analysis in there. You have your CAM operations, NC toolpaths. But in this situation, all of these phases talk to each other, and there's no need for translation of data. So in this situation, data translations are eliminated, which means barriers are eliminated. You don't have to worry about tossing your design over the fence, as they say. Data accuracy is maintained because you don't have to worry about somebody taking your geometry and by accident messing it up a little bit and making a mistake. Third, concurrent design is promoted. You can be working on your part design while somebody's working on the NC toolpath. You don't have to wait until the design is frozen. I mean, I hear that a lot out there. I can't start my NC toolpath until my design is frozen. Okay? The other one is complete associativity is maintained everywhere. So you never have to worry about who owns the newest model, all right? Because the design model is the base of everything. It's the master. And if it changes, everything else will update, and changes will propagate everywhere else. Finally, and this is something that is really key with a lot of people, is ultimately it's cheaper to maintain and train in one system. You don't have to pay all the maintenance dollars, and also it's easier to get people up to speed on one system. Or in this case, what we're going to talk about today are one CAD system, one CAM system, but they're fully integrated, which keeps the UI very similar. It allows you to transition between the two more easily. Now I'd like to introduce Keith Busby from, he's a technical specialist at CNC Software, MasterCAM. Keith, are you on the line with us?
I am, Craig.
Okay, great. So Keith, why don't you tell us a little bit about MasterCAM here?
Okay, well, thank you, Craig. Hello, everyone. Thanks for taking the time to join us today. Like Craig said, my name is Keith Busby. I work in the sales department of CNC Software, the makers of MasterCAM. MasterCAM is located in Towne, Connecticut. We're right about halfway between New York City and Boston. We've been an industry leader for over 25 years and have over 150,000 customers worldwide. One of the most important keys to our success is our dealer channel. Currently, we have over 400 dealers and sub-dealers around the world, and they have an average of about 16+ years of experience just supporting MasterCAM. And many of them actually have worked in machine shops and as machinists before joining us as dealers. So they're an extremely knowledgeable and great asset to our team. Next slide, please. We have a full machine shop at our, actually go back one there, Craig. There we go, thanks. We have a full machine shop here at our facility that we use to prove out our latest toolpaths and technologies. The machine shop currently houses such machines as it's a Mazak Integrex, a Makino high-speed mill. We got a couple of Haas machines. We have a 5-axis machine with a trunnion and extended Z, and we even have a Tsugami Swiss machine. So we really feel it's important that we get hands-on knowledge and really prove out our toolpaths. Our customers range from small shops to large Fortune 500 companies. Some of the customers that we've recently profiled include Raysource, of which the owner Pablo Huffaker uses MasterCAM to machine parts for his Gravedigger monster truck. And he also supplies parts to the other monster trucks on the Monster Jam circuit, which is on Speed Television. We also have Gibson Guitar, who many of us know for making just beautiful guitars. Orange County Choppers, or OCC, which happens to be a joint MasterCAM and SolidWorks customer. And even lately, Hollywood prop makers. We recently started doing promotional material with them. It's kind of interesting. These guys are making props for Hollywood using MasterCAM, and they're using these props in movies such as iRobot, the latest Tron movie, and even the upcoming Planet of the Apes movie. So we might even see some of our results inside Hollywood. It's kind of neat. Next slide, please. One of the key aspects that distinguishes MasterCAM is our separate division dedicated solely to the educational market. We have over 80,000 educational seats worldwide, and we have an extensive learning tools such as MasterCAM University, MasterCAM Quick Part, instructor training, and so forth. We also participate in such competitions as BattleBots, US First Robotics, the Mini Baja team, and Skills USA. So it's a lot of exciting things that we see coming out of universities. Next slide. MasterCAM has a wide variety of products that can serve our customers. Besides MasterCAM for SolidWorks, we have the standalone MasterCAM Mill product, which has been our flagship product for over 25 years. Add-ons to this product include Multiaxis and Port Expert. And Port Expert is a tool that specializes in programming for precision head porting machines. Next slide. We also have MasterCAM Lathe for turning. If you combine that with MasterCAM Mill, you can solve your mill turn needs. MasterCAM Router for woodworking, MasterCAM Wire for your wire needs. And coming soon, we have MasterCAM Swiss Expert for controlling and programming your Swiss CNC machines. Next slide. I want to show you two products today, MasterCAM for SolidWorks 2D and MasterCAM for SolidWorks 3D. The 2D version works in both part and assembly mode, contains traditional 2D toolpaths and our more advanced high-speed toolpaths. We also have FBM, or feature-based machining, and those capabilities allow the program to automatically scan your part and identify the features to cut, and then automatically program your part. The 3D version includes everything in the 2D version, plus our 3D toolpaths. These toolpaths include our traditional toolpaths as well as our high-speed surface toolpaths, including OptiRough, Hybrid, and HEM, and I'll be showing those to you guys shortly. Next slide, please. I want to briefly discuss some of our toolpath technology before we see it in action. One of them that I want to show is OptiRough. It's one of our latest toolpath additions, and instead of using a traditional approach to material removal, where we take a small step down, remove material, and then continue with another small step down, OptiRough takes a large step down, sometimes up to 150% the diameter of your cutter or more, and then uses a dynamic tool motion to remove material. And by automatically adjusting the step over, you have a more consistent load on your cutter. Your cutter lasts longer, it cuts deeper, and it removes more material faster. And then once the cutter approaches a tapered wall, our optional step up settings will create smaller steps upward to remove material from the tapered walls. And then once that's done, the whole cycle repeats itself. The tool does another large step down, removes material, and then a smaller series of step ups. And then our HEM technology, or high efficiency machining, it includes a proprietary speeds and feeds calculator developed by ISCAR. And it's a partnership that combines, in my opinion, the best of both worlds. I look at it this way. MasterCAM focuses on creating state-of-the-art toolpath motion, and ISCAR focuses on developing new tools with advanced cutting technologies. And now with this integration, the two technologies are partnering really to work better together. And when they're used properly, you can take full advantage of what they were intended for. We often see CAM users that don't take advantage of the full potential of these technologies. So with this technology enabled, HEM will dial in a specific speed, spindle speed, matched precisely with an optimal feed rate for what I consider really a no-fail approach method to machining. We've just been seeing really great results with it. So I'm going to show that to you as well. Now, Craig, at this point, you want to switch the control over to me? Okay, let's switch this over. Okay, so it looks like you guys can see my screen now. So I'm going to start with a 2D demo. The first thing I want to do here is I want to create a toolpath called a dynamic core mill toolpath. It's a high-speed toolpath, and this toolpath allows me to enter my part from the outside as opposed to ramping, helixing, or plunging into my part. I'm just going to go up here and activate one of the toolpaths. I'm going to select the faces that I want to machine as well as the faces that I want to avoid. So I can avoid islands and so forth. The nice thing here is I'm not just limited to selecting solid entities. I can also select surfaces, edges, even sketch geometry for the control of my tools. I'm going to choose a dynamic core mill toolpath, and I'm just going to grab a cutter here, 1/4 inch is fine, and I'll accept the defaults. So at this time, MasterCAM for SolidWorks will calculate my toolpath, and when I'm done, I can investigate this. So let's zoom out a little bit. And we'll play this guy just to see what it looks like. So notice how the tool enters from outside and dynamically changes a step over to create a more constant load on the cutter. When it gets into these channels here, it again does more of a constant dynamic motion to really optimize your material fluid rate. This also utilizes the entire flute length of the cutter, and it also extends the tool life greatly.
So one thing you might want to mention here, too, I think is a key thing. Everybody sees the screen, and you notice you're inside SolidWorks right now, right? So that's one of the key things is the fact that we're running MasterCAM for SolidWorks, not just MasterCAM. And
absolutely, yeah.
Keith has full access to all the SolidWorks capabilities as well as the MasterCAM for SolidWorks capabilities.
Yeah, that brings up a good point. The tool paths are not specific tool paths that we've developed for SolidWorks. They are 27, 28 years of proven toolpath technology inside of MasterCAM that has now been able to be accessed through SolidWorks. So if I wanted to continue, maybe I want to machine out this little island up here. I'm going to use another toolpath called an area mill toolpath. So I select the geometry that I want to cut. I choose the type of toolpath I want. Click OK, and within a short amount of time it's done. And if you notice here, again, we don't have our traditional zigzag back and forth type of tool motion. We have this dynamic motion, which allows me to cut deeper and faster with my cutter. Now, if I have a similar piece of geometry, let's say this island over here, I can just take an existing toolpath that seems to work well, copy it, paste it, and then associate new geometry with it. I look at it this way. If you program the geometry and it works, keep it, just apply it to new geometry. So within just a couple of clicks, I copied the toolpath, I applied new geometry to it. So at this point, what I want to do is turn on what's called my verify. In this case, it'll allow me to check this model out and see how it's going to be cut. Now, a really useful feature that brings the power of SolidWorks into the CAM world is my ability to compare my machined model in MasterCAM for SolidWorks. So that is the digitally machined part to the designed part that exists in SolidWorks. So once this is done, I can choose this option to compare my machined model with the SolidWorks model. And I see a little bit of a color code here. This is basically a color mapping to show how much material I'm leaving. And in this case, we can see my machined model here. We can see my CAD model here. And then I can see an overlap of both of them. And you'll see in the upper corner, I have a blue area. That means that I missed material there. Chances are that's probably because I used a larger cutter and I couldn't get into that smaller area. So that brings up a good point here. I can use the tools that are available inside of SolidWorks to check for any minimum radius of curvature. And a tool that I use all the time is my check entity tool. I just choose the option to select the minimum radius of curvature, hit check. It identifies where the minimum radius is, and when I select it, it points out exactly to that area. And it shows me that my minimum radius of curvature is about 100 thousandths. So my quarter-inch cutter could not fit in there. So what I can do back inside of MasterCAM for SolidWorks is that toolpath that went into that area, I'm going to copy it and do a rest machining operation or a rest milling operation on it. So by copying that operation, I'm just going to go in, I'm going to choose a rest mill toolpath instead, and I'll choose a smaller tool, in this case, maybe a 3/16. And then under another parameter here, I can tell it to look at a previous operation, and it'll calculate what material that previous operation missed. And now this new toolpath will only go over that previous, only machine that remaining material that was left behind. So what we can see here, if I zoom into this area, we have just a simple little tool motion here that cleans out that area. And I could also use dynamic rest milling instead if I wanted to do a more dynamic approach to it. A lot of that would also depend on the type of material I'm using. Let's finish up this part. We'll drill out the holes. And in that case, I'm going to use FBM, feature-based machining. Specifically, I'm going to use the drill capabilities of it. What that allows me to do is have FBM analyze my model, look for islands, look for pockets, look for holes, look for anything akin to machine, and automatically apply toolpaths to that based on some rules that I give it. Let me turn off spot drilling. I don't need that. I'll just do some pre-drilling. I can also just tell SolidWorks to detect the holes. And what it will do is it'll identify any hole wizard features that I have. And with those hole wizard features, it'll actually grab the intelligence of that hole wizard feature. If it was a 1/4-20 tapped hole, it'll identify it in FBM and allow me to automatically program that with the appropriate size drill. So I just click OK, and I have my drill capabilities, my drill toolpath already created. When I hit play here, you'll just see, let me speed it up a little bit. It goes through and machines all these holes out automatically. Just to take this one last step before we move on, let's throw a simple design change at this. We have a channel here. I'm just going to go in and change the location of this channel. Right now it's 1 1/4 inches off the wall. I'll change it to 1.4 inches, rebuild my model. So what MasterCAM for SolidWorks will do is it'll identify the geometry that gets affected by this design change, and it will mark my toolpath dirty. So any toolpath that is affected by that design change will be marked dirty, and all I have to do is regenerate my model, and my toolpath automatically gets updated. So even though this was a pretty simple example, and we'll get into a more complex one in a minute, this is really key. With the benefits of an integrated system, integrated CAD/CAM system like MasterCAM for SolidWorks, your design change doesn't stop you in your tracks. And I think that Dan is going to allude to this a little more when he talks in a few minutes. So let me just switch on. I'm going to switch to another model here. So this one's a little more advanced. In this case, what I have is I have an assembly. A unique thing with MasterCAM for SolidWorks is the ability to program in the part mode or the assembly mode. In this case, this is an assembly. It's a mold, and if I isolate the parts, which the isolate command is a function I love. It's great. This is the model that my mold was created of. It's just a key fob for a car ignition. And let me jump back out of isolation mode. And I'm going to open up this model in its own window. So I'm going to open up the mold model. And you'll notice that I already have some toolpaths on it. And this is really just to save time, but I want to go through and look at these toolpaths specifically. This first toolpath is an OptiRough toolpath. And so I alluded to that earlier. The OptiRough toolpath allows me to do large step downs and then smaller step ups. So if I go into the parameters of my OptiRough toolpath, you'll notice that I have a step over option, a step down option, and an optional step up command. Right now I'm doing about 55% of my cutter in depth, and really that's just because this is a fairly small part and I want to see multiple depth cuts. But I could, in some material, I could see up to 150% or more. So if we go in and just do a solid verification of this, we'll see that my material removes as much, my cutter removes as much material as possible and then does optional step-ups, which is key. If I zoom in here, you'll see that it does optional step-ups in the areas where there's a tapered wall. If I wanted to use a more traditional machining approach to this, I would be doing this Z-level cutting at every step down. So every little flat area that you see there, I would be removing material. Okay, so that was the first toolpath called OptiRough. Moving on to the second one, and actually let's back up a little bit. You'll notice with the first one, I missed material over here, and that was most likely because my cutter couldn't fit that there. So using the benefits of a solid model and the power of MasterCAM, I can create a high-speed rest roughing toolpath. And the rest roughing toolpath allows me to remove material that previous toolpaths simply missed. Let me turn off that compare option. We don't need that more. And I'm just going to bring up a stock so we can see a better example of this. So if I play this, you'll see that this cutter now is only removing material that the previous toolpath missed. And in this case, I'm cutting very little air. I'm just attacking the material that's remaining. And then the third toolpath I wanted to show here is our hybrid toolpath. And this is probably one of my best toolpaths. It's a combination of two toolpaths. It's a combination of a waterline or constant Z-level machine toolpath and a constant scallop toolpath. So a waterline toolpath is great in vertical or near vertical walls. But on a more flat area, that waterline toolpath loses its power because now you have large step downs in an area where you really need to minimize the step down. So at that point, the intelligence of our toolpath automatically switches between waterline and constant scallop toolpath. And we can see this. If we go into my verify again, I'm just going to change my stock so we can look at a better example of it here. We'll see that, let me slow this down just a little bit. We'll see that we'll do constant Z-level machining or waterline machining around the vertical walls. But then as it slowly starts to taper towards the center of this model, it's going to actually convert over to a constant scallop toolpath. Maybe this was a little too slow. We'll speed it up there. So we'll see that as this toolpath is collapsing towards the middle, it'll slowly morph from constant Z-level machining to a constant scallop machining. Because right in this area that is cutting now, if I was doing Z-level machining, I'd see some pretty big step downs. Okay. So now let's throw a design change at this. If we wanted to really create a mold of this, I'd want to go into my tools inside of SolidWorks, in this case draft analysis, and look at some of the walls here. And let's just see here. The yellow wall that my mouse is hovering, this has got looks like a 0-degree draft to it. That's because in my model, there's no draft in it. So what I'm going to do is switch back to my assembly, and I'm going to open up my part that the assembly utilizes to make the mold. In this case, it's my key fob part. And in here, I have a draft feature that's suppressed. I'm just going to unsuppress it for the sake of time. But what this feature is doing, the draft feature, is it's just adding draft to any area above this parting line. So my faces here that are selected, that's where it's adding draft to. And if I go in, save that down, close my model, I get this message that we always see inside of SolidWorks. It's going to update my assembly, and that's perfectly fine. That's what I wanted to do. So now it updated my assembly, and then from there, if I go back to my mold, what MasterCAM for SolidWorks will do is it looks at my model and identifies areas that the geometry changed. I'm seeing a little bit of flickering on my screen. I think it happens to be my GoToMeeting here. But what's happening is MasterCAM for SolidWorks is looking at the geometry, identifying areas that were changed, and it's marking those toolpaths dirty. So any toolpath that is cutting a surface that changed, it marks it dirty. So at this point, all I need to do is select my toolpath that I want to rebuild, click on the Rebuild button. MasterCAM for SolidWorks will recalculate that toolpath. Now, this is, in my opinion, this is huge. With the benefit of an integrated system, like I mentioned earlier, a design change doesn't stop you dead in your tracks. All you do is you make a simple change to your model, your toolpath updates, and at this point, I can go back into Verify it, I can go back into Backplot it. I'm no longer limited by a design change. I don't have to stop and reassociate my toolpaths. I just click a button and go. And one last thing, I realized I had not mentioned this earlier. I talked about HEM briefly. What that is, the high efficiency machining, it gives me the ability, like I said, to select a tool and my feed rates automatically are dialed in precisely. I just want to kind of show you that interface here because I skipped that earlier. So we have a whole list of tool libraries to choose from. If I grab, for example, my ISCAR inch library, and I just grab a small cutter, it'll identify that this is an ISCAR tool, and it allows me to turn on the HEM. And with HEM turned on, I can use the slider bar left or right. And as I drag it left or right, you'll see my feed rate and my spindle speed are automatically dialed in and the grayed out, and I can't update that. The interesting thing, too, is if I go too aggressive, I hit the maximum limit of my machine. And it even tells me that. It says your machine is now limited. You can't go faster than what you're putting in here. So that's really the power of the partnership that we have with ISCAR, and then obviously combined with the partnership that we have with SolidWorks. this is just an awesome set of tools that we can use to machine all of our parts. So at this point, Craig, I'm going to pass it on back to you.
Sounds good. So Keith, I just want to emphasize, and you did a great job there. You know, how many times when you're doing mold design or any kind of design where you're dependent, where you're really dependent on a designer to constantly make the changes for you, or it's in another system where you have to go, hey, can you change that part for me in that other system? The fact that everything's fully integrated here, you can just instantly jump back, especially in mold design. You're constantly changing things like radii and drafts and things like that so that you can actually machine the molds. And to have all that in, the power of all that in one system, basically, one fully integrated system where you've got the power of MasterCAM and you've got the power of SolidWorks all in one area. I mean, it lets you just jump back and forth seamlessly. And you know, as you were going through that, Keith, you know, yeah. I was even getting lost. Seriously, are you in SolidWorks now, or are you in MasterCAM? You can't tell because they're so similar that you really have to look to see what you're in. And that's, I think, one of the most powerful things is that you guys have done such a great job of integrating your products inside of SolidWorks too. It's very seamless, and it really shows up in a demo like this.
Awesome.
So what I'd like to do now is introduce Dan Martin. Dan, are you online right now?
I am, Craig. Can you hear me?
Yep, I got you right here. So Dan Dan's with Summit Tooling in McHenry, Illinois, and Dan uses both SolidWorks and MasterCAM. Dan, I'm going to let you do the talking. You did a great job the other day when we just kind of spoke about what you wanted to talk about. So go ahead.
Okay, as you can see, we've been in the mold making business since 1996. We started with SolidWorks back in 01, and we actually used MasterCAM from 1997. So we've had both systems in here for a while, and when they got integrated about a couple of years ago, it made a significant difference on how fast things ran through our shop. And you guys really targeted, especially Keith, on the fact that, you know, we're a prototype product developmental company. So we build tools from an entrepreneur level to small companies to Fortune 500 companies, and we service all industries: medical, consumer products, electrical components, packaging. You know, we do a little bit of automotive as well. So we see all of these different types of tooling, molding, and all of that goes into that. But what I want to make a point is that once this was integrated, we no longer can I have you flip the screen back to the stop sign one?
Yeah.
This one really hits home with us, and I can't express this to the listeners out there, but everywhere you see the red window, that's like a stop sign to us. He is spot on when he says that we were designing parts, then going and importing it to a different system, throwing toolpaths at it, putting it back in, moving it, shifting it. It takes time to do this, and it eats up memory. The whole thing is slowed down dramatically. The accuracy of things. We would have things throughout the shop that were design changes in process, especially being in a prototype house. We are under the gun for quickness. That's our claim to fame, is how fast can we get this prototype done to market. They're making design changes a lot of times on the fly while you're building the molds. We have to be able to import those changes and make it all associative. Maybe it's a change on an electrode out on the floor. Maybe it's a change on some high-speed machining out on the floor. But we have to get that in there and get it quickly in the system to all of the guys that happen to be working or associated with that particular tool or that particular cavity block or core block that they might be working on. The time savings here is tremendous. You will have less mistakes. We don't have mistakes like we did years ago where a guy might change something on one system, but it doesn't get updated in the toolpath and they miss it. Now, everything is together and associative, so that's a huge, huge point. Ultimately, it's cheaper to maintain and train people as well. Now, we've been using MasterCAM for a number of years. A lot of the junior colleges teach MasterCAM, and a lot of junior colleges teach SolidWorks. From a business owner's aspect, it is phenomenal that I can hire a guy off of the street that knows MasterCAM or SolidWorks and easily show them this integrated system, and they pick it up. It's awesome. Can you go to the next screen?
Yep.
This is showing, again, some of the products. This is actually a medical component that we designed this component from scratch, debugged it, made it into a prototype, made it into actually a production tool. Today, this product's in every Walmart in this country. It is an ear cleaner, and as you can see, here's a product that came from start to finish very, very rapidly, and it's a huge success. The other thing that I want to note is the paperless mold design and manufacturing. We, as prototypers, a lot of times we are, creating, years ago we would create prints and whatnot. Now we still have to create prints, but typically it's only for reference only. A customer may want the tool design, for example, which we still create out of SolidWorks, but typically for the manufacturing process on the floor, a lot of prints have been eliminated. The big difference here is when we design a tool, we design it in solids. We're initially creating electrodes and toolpaths at the design level before it even hits the floor. So we're already determining in one step how we're going to build this mold from start to finish. So when it gets out on the floor, now it's going to the tool maker. It gets broke apart. The pieces go to this machining center, this wire cutter, this EDM. Everything is broke apart. The path is already chosen, and SolidWorks, MasterCAM for SolidWorks makes that easy because now everything is chosen at that design level. Years ago, we would design a mold, put it out on the floor, and then the tool maker would label tool paths to this trode or that trode, or they would decide. And what we would have then is an inconsistent build on the tool. You might have a really good tool maker in one area and a really slow tool maker in another area. You might have the same result at the end, but the time required to build that mold could be significantly different. After we implemented this, as you can see, 09 was the date that they did this. We were already using the latest MasterCAM, and it's phenomenal by itself. But once they put it in SolidWorks, it was earth-shattering for us. I'm here to tell you guys out there that doing this is probably the best bang for the buck you're ever going to see. Yeah, shorter lead times, absolutely. We have a better control of it. And a lot of times we have to, in a prototype field, make multiple changes to a part while it's under constructing, not knowing which of those changes is going to make the customer's part fit, function the way they want it to. Sometimes changes will be taken out or put back in, and once those changes are done, everything is associative, so the final mold design that goes out of here is exactly how they want the production to be built. So a lot of times we'll take that and send it to the production mold builder, or perhaps sometimes that's even us, but it makes the job extremely easy. The other factor that I do want to stress is that last statement down at the bottom, that 50% bump in productivity is real. I would say since 08, our profitability has skyrocketed beyond belief, and I would say we're probably at a 50% productivity level. It has just increased phenomenally. I don't know how to put it into words, but other than that statement,
yeah, I think that's pretty
08 was a tough year, I think, for all of us. And coming up to where we're at today, I know a lot of businesses are doing quite well, but this is a tool that will change your whole methodology. Again, we were using both softwares, and once the marriage of this happened, It takes it to a new level. The other thing that I do want to mention is you saw on the slide that Keith was doing the implementation of ISCAR tools that he placed in there. We actually do utilize the HEM and the OptiRough. Those two products are unbelievable. To see it, they came in and showed us it face to face. Of course, my guys had questions. We saw what it did, but that takes the guesswork out of things. It makes it so efficient and quick. Sometimes I think I'm old school, but when I see what goes on and the programming techniques that are done these days, it is completely different than you can even imagine.
Hey, Dan,
yes,
there was something you brought up too yesterday, which was, you've been able to move a lot more towards being a product development company too, right? Where as far as the way you work with people and you're able to provide, more services, that type of thing too, you were mentioning.
Yeah, the fact that we do get customers that are entrepreneurs that just have an idea or a concept. We can design the component. We actually do run mold flow on it to check to be sure that we're getting a good fill on the part and that type of thing. We will build the prototype, debug it, get them product, and take them all the way to the production level. But this product using SolidWorks, you can do all that. We get SLAs made right off of this, creating SLS files, that type of thing. It lends itself. You're exactly right. There are so many other avenues in here that this software gives you. It gives you flexibility. It gives you accuracy, and it's fairly. Let's face it. Again, I got to go back to the ability for people to learn this software. I know I can't mention other competitors, but there are other ones out there that require a lot more of a learning curve. And let's face it, we're all in a trade these days that we need to produce stuff quickly and accurately. And the less amount of training required to run that software effectively is a huge savings in itself.
Great. So I'm trying to think, is this the, did we have another slide? Okay, nope. So Dan, did you have anything else you wanted to add, or?
That's about it. Our experience has been really positive with this, and
I think one of the things you mentioned,
again, our profits have gone up and up and up. Even in 08, during that bad year, we were still climbing, and MasterCAM has been with us all the way. And we have tried other softwares, and I think there is nothing out there that comes close to MasterCAM's abilities.
I think one of the things you said too, you were actually one of the people who beta tested MasterCAM for SolidWorks too, and you were mentioning the response rate and stuff like that you were getting. I thought that was interesting.
Yeah, we did do that. We were the beta test platform for these guys, and it was eye-opening. Again, having both sides of the fence with MasterCAM, we were really efficient with that. We knew SolidWorks really well, and when that, it's kind of like if you think it and then it happens, you're like, wow, I wish I'd have thought of this before, because it's so earth-shattering to see and to utilize. It's like, boy, this should have happened 10 years ago, But it is truly amazing, and I can't express enough about the profitability is going to change, your productivity is going to change. It's at that design level. Let's face it, a bad design at the beginning, you're going to turn out bad work at the end. And
I think especially when you're talking about complex parts, especially when you're talking about molds and plastic parts, but also just machine parts. I mean, you're constantly, when I was doing mold design stuff, I'd be going back and forth constantly, because you want to be able to go in and create clean parting lines and things, and to do that, you have to make sure that the geometry is properly, you have your proper drafts on there, you can set your pull directions and all that. So the the dependency of manufacturing is really on good design, good part design. Otherwise, you're going to end up making parts that come out of molds and parts that come off machine tools that are different than the ones being designed. And I think having that link is a key thing.
Yeah, and we actually, it's funny you mentioned that. We've had instances where customers come with us with designs of parts, and we manufacture them, and the part comes out, and they go, okay, you guys must have made an error here. This is not the part that we designed. And I say, well, we cut everything right off your part model. All the toolpaths come right off that model. Everything is associative there. We can't affect what is cut. And they pull the part up and they say, wow, there is an error. There is a draft angle that is not, that's what was on the model. And we catch mistakes actually on part models right from the customer.
And that's using the draft check functionality, I would imagine, and undercut and things like that.
Sure, sure.
Yep. So there you go. I think that's one of the key things, too, is people find there are some of the checks that you have in SolidWorks that are for manufacturing. So you have like your geometry check, like draft check, undercut check. You've got bad geometry check. By the way, did you also know about when you want to see the differences between two versions, an old version of a part and a new version, you can compare the parts to each other. Physically, what it does is it lays the models on top of each other in SolidWorks, and it tells you the differences. It says, this material was added, this was removed. And that's called part difference in SolidWorks. It's under utilities. So that's something else. That's another way that SolidWorks helps manufacturers to figure out, what is coming up and what changes are going to happen, and how do you have to tweak your part to make it manufacturable. Then you combine that with MasterCAM for SolidWorks, and it's, obviously there's where your time savings are. So, hey, Dan, I really appreciate the time that you put into this, and thanks for all your comments and everything. It was very good. And our conversation yesterday was a lot longer, obviously, and I really appreciate all the input that you gave us and the ideas and everything. I'm going to, just because for time reasons, I'm going to let Keith come back to finish up with kind of a summary. Then I wanted to get to everybody's questions. And if you do have questions, please, in GoToMeeting, if you open up your panel, your GoToMeeting panel, there's a question area right there in GoToMeeting. And you can type in your questions there. And in a few minutes, we'll answer those questions live. So if you could do that right now, while Keith, can you give us kind of a summary then?
Sure, yep. Can you advance next slide?
Yep, sure.
Okay, going along with the comments that Dan had said, I just wanted to add two quick case studies about our HEM partnership that we have. One of them was a customer that was using a pre-hardened PCS mold base. And just their original programming time, which was pretty decent, was an hour and 15 minutes. They decided to choose an ISCAR feed mill and use one of our dynamic motion toolpaths, and they knocked it down to 45 minutes. And then they turned on HEM, and they knocked it down to 15 minutes. And with the HEM, there wasn't any guesswork. They clicked on the slider bar, chose what they were comfortable with, everything else dialed in. They had a 5-to-1 productivity game. Next slide.
Yep.
And then the other one was just a customer had an aluminum mold. They looked at the mold and they quoted 6 hours for the job, and they finished it in 36 minutes. And it was actually, it was a complaint that we got. The guy complained. It was a funny complaint, but he said that he couldn't get the chips removed fast enough, and he needed to upgrade it to a higher speed chip auger. So we actually have the email of that. It was pretty interesting, but it really just shows the power behind it. So all these technologies coming together is just great. Next slide. So just to recap, we saw this fully integrated right inside of SolidWorks. So we're programming with proven MasterCAM toolpaths right on the solid model. And we're using our advanced toolpath technologies when we're really embracing the latest machine tool and cutting tool advancements, utilizing partnerships wherever we can. Next slide. And we're supported by an experienced and very dedicated dealer network. And coming soon, people have been asking about our Multiaxis and our lathe and so forth. We have plans for all of that. We want to lay the groundwork out and make sure it's powerful and strong and stable. But you're looking at Multiaxis, Port Expert, Blade Expert lathe, all coming in SolidWorks in down the line. But with that, thank you very much, Craig. I'll pass it back to you, and you can take over.
Sure. So in summary, on the whole presentation today, again, please, if you have questions, type them in. Open up your GoToMeeting panel, hit the arrow. You'll see an area called questions, and if you go in there, we're going to scan through those questions in just a minute or two here. So just in summary, you know, what we're really focusing on here is MasterCAM for SolidWorks as it being integrated inside of SolidWorks, the benefits that you get. And I think one of the key things, I mean, is what Dan said. Dan, as a user, saying, you know, I can say it, you know, as a product manager, and you know, Keith could say it as a technical support person, but you don't believe it until you really talk to somebody like Dan who's using these systems, and he says, I'm seeing a 50% boost in profitability in his ability to turn parts around and get things out the door, and how that translates directly to money. And let's face it, that's what it's all about. It's not about you know using a cool tool or even seamless integration of SolidWorks and MasterCAM for SolidWorks. It is all about how much money am I going to save or make, or how quickly can I get these designs out the door. That's really what it comes down to. And I think Dan did a great job of really emphasizing, you know, his experience by using these two products together. Anyway, so just in review, the integrated design solution, design through manufacturing solution, eliminates data translation barriers. It ensures accuracy of data throughout the design process, promotes concurrent design. You don't have to wait for the design to be frozen. You can be doing your NC toolpaths earlier, and you can be making design changes and seeing those design changes update automatically because of associativity that you have inside of SolidWorks that propagates to the MasterCAM toolpaths. And then finally is the one thing that Dan mentioned was the availability of resources of people who already know these products, which means that people who already know MasterCAM and MasterCAM for SolidWorks and SolidWorks, because these products are so prevalent in the education areas, that you have a resource of people who already know a lot of these products, and they can be instantly productive coming out of you know, out of schools, out of you know, technology classes and things like that, that they're able to, you know, be instantly productive for you. So you know where to get more information on SolidWorks, solidworks.com. For MasterCAM information, and specifically MasterCAM for SolidWorks, all one word, mastercamforsolidworks.com. Again, we'd like to thank you for participating or attending today's session. I'd like to now open up the question area. And what I'm going to do, Keith and Dan, because you can't see the questions, can you see the questions, Dan?
Yeah, I can see I see a box, yes.
Oh, okay. Okay, so what I'm going to do is go through some of these questions. We got quite a few. Oh, boy. Let me get to the top. Wow, we have a lot. Wow. Okay. I don't know if I'm going to be able to get to everybody's question, but let's answer a few. What we'll do, folks, is since there are so many questions, first of all, I always get this one. Is this recorded? Yes, this session will be recorded, and we will be posting that recording. You'll be getting an email where it's going to be located, and you can download it over the web. Oh, we had some problems in the beginning here, so there's some questions on people couldn't see what was on the screen. Okay, here's the first one. Will FBM drill work with the custom hole wizard? So feature-based machining.
Yeah, if you're referring to using the hole wizard and modifying some of the features of that, as far as like the different size holes and so forth, if that's what you're referring to, I believe it will. You can also do what's called hole mapping. So for whatever reason, let's say every time you have a 202 size hole, and that's going to be your 1/4-20 tap hole, you can map that in an Excel file to automatically apply a certain type of drill to it. So you're using the whole wizard feature, but you can break the barriers if you want to and use your own based on your own experiences as well.
Okay. This question, MasterCAM for SolidWorks provides some, I guess it's a, does MasterCAM for SolidWorks provide some possibility to edit the toolpath directly from the modeling area without having to model the NC code, modify NC code? Does that make sense? What I just read, maybe I'm not reading it right.
The possibility to edit the toolpath directly from
the modeling area. Not to, oh, okay, maybe, okay, if I'm reading this, I'm thinking the answer would be yes, because if you modify the model, in other words, if you go directly into the model and make a change, you can say update the model, and immediately MasterCAM for SolidWorks will tell you, okay, the model's been changed, your toolpath, your NC toolpath is now dirty, meaning it needs to be updated, and then you can click update at that point, and it will automatically update. Am I right on that, Keith?
Right. We have a switch to automatically update it. It is a configurable switch for the user, just because, just like in SolidWorks, if you have 10 modeling changes you want to rebuild after you're done, you know, we have that ability as well. But yeah, so modifying the model will certainly allow you to update your toolpath. Yeah, if that's the question that you're asking, I absolutely, yep.
Okay. Oh, that's good. So you do have the option.
Yep.
Okay. So it's like somebody answered another person's question. Okay. Okay. Will MasterCAM for SolidWorks, or can MasterCAM for SolidWorks use older toolpaths written in regular MasterCAM, older MasterCAM?
Yes, you can import toolpaths from older, I don't want to say older versions of MasterCAM, but older style toolpaths. You certainly can import them. It's also important to note as well that if you have MasterCAM for SolidWorks and you're programming your SolidWorks part and you're creating toolpaths, you can open up that SolidWorks file directly inside of MasterCAM without going through translators and bring in all of the toolpaths that you created while inside of MasterCAM for SolidWorks. So right now, this key file part, I could open that up inside of SolidWorks. All my toolpaths would be there, and I'd continue. I could open it inside of MasterCAM, and all my toolpaths would be there, and I could continue machining it. So yes, but to answer your question, we certainly can bring in importing toolpaths from MCX files from MasterCAM. Yep.
Now we've got a unsolicited advertisement for the Connecticut. You knew this was coming, Keith.
Well, you know, actually, it's good to mention that. If you're talking about from Ed Gibo, I'm very happy with the partnership that we do have with SolidWorks. And one of the things we're doing is we're hosting the first SolidWorks user group at a partner, I believe, and it's going to be here June 9th at our Tolland office in Tolland, Connecticut. We're going to have our full machine shop running. Every machine is going to be running. We're going to have SolidWorks users from around the area coming in. And it's just a great example of really the partnership.
So that's June 9th, Tolland, Connecticut, at the MasterCAM headquarters in Tolland, Connecticut.
And if you dig around the I don't know the direct link, but if you dig around the SWUG websites, you can find the link to register for it there.
Thanks, Ed. Let's see. It says, okay, it says, what steps are necessary to make MasterCAM recognize the design changes and then adjust the toolpath to those changes? So again, I think the answer here is simple. You really don't have to do anything other than click the button because it's already inside SolidWorks, and that's the key.
That is correct.
Yep.
Yep.
So
yeah.
I think that's the thing. There's no magic happening as far as, we're not, there's no smoke and mirrors. It's just the fact that MasterCAM now, with MasterCAM for SolidWorks, MasterCAM is running directly inside SolidWorks. So as the model updates, as the design model updates, the NC toolpath can update automatically also. Okay. 5-axis machining yet? I don't think so, right? MasterCAM for SolidWorks?
It's coming. Yep. Yep.
Coming. Okay.
Multiaxis and Port Expert and Blade Expert, which are specific modules for machining out cylinders and ports, and also blades and propellers and so forth. They're all coming. We just, we're just kind of tidying it up now and putting last minute finishes on them.
Yep. Now, what about turning? Because there was another question here on turning. MasterCAM for SolidWorks and turning.
Yeah, it's also in the works. Absolutely. A lot of this is being demanded from our customers. That's really what drives a lot of our products, and this is no different. So they've been requesting it, so we're adding it. Absolutely.
Okay. All the questions. I got all these questions right here, all related to these two topics.
Well, that's good to know.
And they're all 5-axis and turning. 4 and 5-axis too. I got another one that's 4-axis also. Mm-hmm. Is 4-axis coming?
Yep. Oh yeah.
Okay.
Axis up now.
Yeah, there's axis substitution now. Tombstoning type stuff, absolutely. But you're doing your more simultaneously 5-axis. That is also coming.
Okay. Let's see. Okay. Similar questions. Hold on just a minute. Oh, says what level of SolidWorks is required to run MasterCAM inside? So MasterCAM for SolidWorks, what level of SolidWorks do you need?
The base package. It also runs on an educational seat because we sell to the educational markets.
Okay.
I believe some of your other partners, Craig, have OEM versions of SolidWorks, and I don't believe that enables you to run add-ins. Is that correct?
I'm not sure.
Okay, that's my understanding, and so we would not be able to run in. If you bought a specific product or machine and it comes with an OEM version of SolidWorks, I don't think we run in there.
Okay. Yes, so it says, is the MasterCAM program a separate file from SolidWorks? Yes, right? I mean, you're not using our install area, right? You have your own install area?
Our install is a complete separate location, 64-bit compatible as well. And as far as the file itself that contains the toolpath, it's contained inside the SolidWorks file. Just like, unless you guys change this, just like your Cosmos FEA stuff can be integrated into the CAD model. So you don't have to worry about a separate toolpath file.
Right.
Hey,
So as far as
I want to mention one other thing. You just mentioned 64-bit.
Yeah.
When we were on 32 and we went to 64, huge difference. Huge.
Yeah, absolutely.
So I would highly recommend that if somebody's asking that question.
Yeah, we're seeing a lot. That's a good thing. A good point is we survey our customers to see what they're buying, and there's been a big shift to 64-bit. That's something that we were just talking about the other day. It says, and I think this is the answer we just got. Does MasterCAM within SolidWorks save the CAM data with the SolidWorks part file or separate files?
Yeah, so it's same file. So the files, it's a SolidWorks, it's a SLD PRT file. The toolpath data is in that file.
Is inside that file, so you don't have to worry about chasing around separate files.
Right, and if I were to email you my CAD file with toolpath data, and you just have SolidWorks, no big deal. You just don't see the toolpath data. When you send it back to me, I'll see the toolpath data because I have MasterCAM for SolidWorks.
Okay, good. Let's see. We have one more question because we're kind of out of time. We actually ran over a little bit here. Are the calculated feeds and speeds based on the material you are machining? If you change the material, what will happen? So I think, you got an answer on that one?
Yeah, they have a bunch of options. You can have it calculate the speeds based on the material you're cutting, based on the cutter you're using, based on the ISCAR HEM options, so a lot of different opportunities there. Everything that's populated by default is based on settings in the machinist handbook. And I see a lot of times when I teach SolidWorks, when I teach MasterCAM, people change those settings anyway because they're more comfortable cutting a certain way. But yes, to answer the question, we can control the speeds and feeds based on the material, based on the type of cutter, and so forth. Yep.
And with that recommendation, with the OptiRough and the HEM, and I know they're showing ISCAR cutters in there. We've actually utilized it for other brands of cutters that we use, and utilize that option in the system, and with some surprising results that were pretty positive.
Yeah.
And one last question. So this is MasterCAM for SolidWorks upgraded yearly? Who manages the technical support and integration issues? So,
the technical support and the integration issues for MasterCAM for SolidWorks is handled by your dealer that sold you MasterCAM for SolidWorks. We recognize that there's MasterCAM dealers out there that are exceptional at MasterCAM, and that's all that they do, so they would not sell you SolidWorks. They're probably not even a dealer. Likewise, there's SolidWorks dealers out there that are not MasterCAM dealers. So most of our dealers are partnering with SolidWorks dealers if they're not dealers themselves. So MasterCAM supported by MasterCAM dealers, SolidWorks supported by SolidWorks dealers.
And there are a lot of dealers on both sides who are, go both ways. So I think that's a key point. As far as the integration issues from a product standpoint, SolidWorks and MasterCAM work together, everybody. So, we're constantly making sure, especially as MasterCAM is a gold partner, making sure that our products run together inside of, that MasterCAM for SolidWorks runs with SolidWorks. There's, all sorts of collaboration that goes on there every time a release comes out. So that's something that, you don't see. It's happening behind the scenes. It's just the typical things we do when we release products. So that's about all we have time for. We'll try to answer these questions. I'll get, these are mostly MasterCAM questions. So Keith, I'll get these over to you.
Perfect, yep.
I'd like to thank Keith for being online with us today for MasterCAM, and also Dan, thank you very much. Thanks for your talk yesterday. Everyone, I thank you, everybody, for staying on with us today. Hopefully you got something out of this. I hope you did. Please look to the future. We have our next webinar series coming up, number 4. We'll be featuring another SolidWorks Gold CAM product partner, and that will be coming up sometime in June. We'll let you know. Thank you very much, and we'll see everybody later.
Thanks, everyone.